So I'm Drew McDaniel. I'm lead program manager in the Azure team. I focus on our infrastructure as a service and really how infrastructure as a service is used within the enterprise customers, a little bit more of a focus on the Windows side of the house as compared to Linux, but we'll cover both of those. And in fact, infrastructure as a service was really kind of started with both Windows and Linux as it launched. So through the session today, and being from the product team, I do have a couple little special gifts, if we will, some prizes to give out. So instead of the basic swag, what we actually have here is some of the ship gifts that we had in the team. We will call these candle holders or shot glasses. And so I've got some questions through the session, and at the end, if anybody stumps me on a question, I've got a handful of these to give out for those folks. So to kick it off, let's actually get into this with, does anybody know when Azure started? When was Azure either announced, preview, launched? Was the answer back there? 2008, correct. So Azure was announced at PDC in 2008. Who said that? Give me a name. What's your name? Okay. So here's for the second one in. And then now, so that was Azure launched. It was really a focus as a dev-centric platform. We still have a ton of dev-focused features. In my mind, when was when was Azure available for the IT pros, the broad swath of customers, when we launched infrastructure as a service? Anybody have a guess when infrastructure as a service virtual machines launched in Azure? 2012? Right there, yeah. Shot glass here afterwards. So we're going to be digging in and talking a lot about, infrastructure as a service and as it applies into Azure, if the clicker is going to work. All right, we're going to go off this then. There we go. So today we're going to talk about the differences between classic and ARM virtual machines with a focus on how to get from classic to the infrastructure service virtual machines, the ARM virtual machines. We're going to go through a little bit more detail as far as what's the best kind of configuration to use. Based on the application you have, we have a large number of virtual machine sizes. We just announced more sizes this week. How do you pick with what to use based on the application? We'll cover that. Then we're going to look at specifically the ARM templates. I'm sure you've heard a lot about the ARM templates, the use of ARM templates. The new portal is really built on these templates. And we're going to dive into how you edit, how do you create, and how do you modify these templates for your application. And we'll start with the building blocks that we have within the platform. We're going to cover how to run virtual machines in a production environment so you can have confidence in running those in a very high reliable scenario. And finally, we're going to hit on troubleshooting and how to troubleshoot those virtual machines. So Azure, currently with infrastructure service, there's two sets of virtual machines, or two types of virtual machines that you'll see. Classic virtual machines managed by classic APIs, and you actually have on the left-hand side here, the classic portal. And then the resource manager, or the new portal, now our currently GA portal, manages resource manager virtual machines and classic virtual machines. Now the key thing here that I really want to make sure that it comes through is that it's the management stack for those machines that is different. The underlying resources, the VMs, the network, the storage, is the same in both classic and in Azure in Resource Manager. It's just that management stack that has been modified. Now, because of that management stack being modified, it has enabled us to do some really great things with Resource Manager that we were not able to do in the classic model. The classic model was very monolithic. As you see there, it really was one large component. That component actually manages all of the virtual machines around the world for Azure within a single Azure cloud. So the scalability was a little bit less, the robustness was a little bit less, and then the network, compute, and storage were all part of one component, which actually led to slowness in being able to update, to fix things, to innovate. And so that separation into the multiple resource providers allows for much, much faster updates and deployments and configuration. It allows for machines to be deployed much faster as well. So you can make updates to a virtual machine in the CRP, then add a disk immediately afterwards, make a modification to another machine, where in the classic model, if those were in a single cloud service, you had to make one update, wait for that to proceed through, make another update. But when it comes to migration, because these things are, just the management stack is being changed, the machines don't modify, it's much easier to do migration. Now let's talk a little bit about ARM and why we really think that ARM is a great solution. The resource manager, everything is deployed within these things called a resource group. And really there's two fundamental ways when you're approaching deploying those resources. Either do a single resource group for the application, is what we're showing here on the top, where you set all the applications together, you put them in a single resource group, and then you can put a security principal on that resource group and delegate that management of that group as a whole out. The other model is a more separated model where if you have one group that works on, say, the web tier and another group that's working on the mid tier, separating them into separate resource groups allows you to do the permissions there separately. A common pattern we see is that customers putting the networks in a separate resource group when they have a network operations team that is separate from the compute operations team. And so it allows you to deploy the VMs without giving the customer or the end user the ability to modify the network and the network configurations, and allows that separation of tasks. Within virtual machines, within ARM, one of the major advancements that we have is this notion of tags. When you deploy resources in Azure Resource Manager, you can set tags on those resources. And those tags can be used for quick viewing in the portal, but even more powerfully, those tags can be used to show up in the customer's bill. And so when you look at the detailed usage for any subscription, you can pull up and see those tags, and they end up showing up here. Let me zoom in a little bit here. Sorry, can't zoom. Show up in the bill, and you can actually pull those tags out. You can parse those, and then those can be used for chargeback to the division, to the group that you want. We also have very fine-grained permissions control through role-based access control within the resource manager. For each resource, you can set permissions at a subscription level, a resource group level, or the individual resources. And when you set it at the higher level, it inherits down to those other resources. Every resource has, by default, a contributor, owner, and reader permission. But each resource has customized resources. So for example, the virtual machines, there's a virtual machines contributor role that gives you the ability to delegate to that role just the rights to create and update and modify virtual machines and not do anything else. But if you want, you can actually combine those. You can create custom roles within Azure Resource Manager and then assign those custom roles to either groups or individuals within your Azure Active Directory tenants. So now I want to look at the migration process. So here's what the process you go through when you're migrating a classic set of virtual machines to Resource Manager. So just show of hands, who has classic virtual machines in use, in production? Okay. And then ARM virtual machines? Good, okay. Let me just start off. If you don't have either, or you're just starting off, you definitely want to start with the ARM virtual machines. The ARM virtual machines are the ones that have more functionality available out of the box. That's where we're spending most of our time. That said, if you have classic virtual machines, we are still investing a lot of resources in security, reliability, robustness, and uptime of the classic virtual machines. And so there's really no reason to move off of classic virtual machines if you don't need some of those new features. Specifically, if you're using classic virtual machines with a cloud service or web worker roles, still stay within the classic model. And in fact, we've just announced a new solution called VNet peering, where you can take a virtual network that's in the Azure Resource Manager side and peer that directly into a classic virtual network. And so you have that connectivity. You don't have any kind of a limitation on gateways that slow down the traffic. You don't pay for those gateways. And so you're able to interoperate classic and Resource Manager pretty easily. But if you get to the point where you're ready to migrate, let me just walk you through what happens. So you start with the classic virtual machines only, and you can read, write, update, modify those. you run a validate command, or you can choose to run a validate command that goes and checks to make sure those machines can migrate. There's no problem, if there's no classic resources there that could not be migrated, and the validate command will give you that warning. Once you've gone through that, you can go through the prepare step, where we lock both sides of the classic and the resource manager so that those resources can be migrated over, validated that they're correct. And once you've validated that they're correct, you can either, if there's a problem, abort and go back to the original state without deleting, without changing anything, or commit that and you end up in the Azure Resource Manager. Now let's look at that with some specific machines. So what we have here is the state on the left is the classic APIs, the state for the machines while they're in classic, and the state on the right is the data that's space for Azure Resource Manager. And the Azure Resource Manager has the CRP, which is Compute Resource Provider, Network Resource Provider, and Storage Resource Provider. So what happens in the validate process? It goes through and just checks the data, doesn't modify anything. When you go to the prepare step, it locks those APIs and starts migrating data across. At this point in time, if you were to go into the portal, you'd actually see two entries. So I started off the classic entry is what we see above there, the migrate test 1. And in the prepare state, the dash migrated version is there as well. I can look at those, I can check those, I can make sure that everything looks right. The machines are still running, the network is still there, I haven't changed anything in that space. I just make sure everything looks correct. If it is correct, then I go through and do the commit. The data is removed from the classic, the APIs are unlocked, and now you're ready to go and everything's working within the resource manager side. Now a few things, the scope of migration specifically, VMs can either be, if the VMs are in a VNet in the classic, every VM in that VNet and the corresponding storage accounts need to be migrated as one entity. So you migrate the VMs in the VNet completely across. In this model, there's no downtime for the VMs, there's no reboots on the VMs, everything just goes across without any impact on what we call the data plane. However, if the VMs are not in a VNet, so in the case of classic VMs, you could choose to put them in a VNet or not to be in a VNet, while Resource Manager VMs are required to be in a virtual network. And so if the VMs are not in a VNet, there will be one reboot while the machines are moved into a virtual network in the Resource Manager side. You have the option to move them into an existing virtual network in Azure Resource Manager or to have it create a new network for you. Now, after migration, there's just a few things that do change. Certificates specifically, so in Classic, again, it's that monolithic model. The certificates are replicated into Key Vault. So Azure Key Vault is a solution in Azure Resource Manager where your certificates and secrets can be backed by a hardware HSM. It's a much more reliable solution. So those are pulled out of the cloud service and moved into Key Vault. Endpoint ACLs are replaced by a solution we call network security groups. You can think of network security groups really as a superset to endpoint ACLs. The endpoint ACLs were just on the network endpoints that you have, like a public IP address or a load balancer, and the network security groups can be applied there or can be applied to a subnet, and so you can actually have much more flexibility with the network security groups. And then there's a minor change in the internal DNS configuration. It continues to work on both sides, but there's just a minor change there. And then the tooling change, so the major change, if you have scripts, if you have tools that were managing classic resources as you've moved them across, the API interfaces are substantially different. The models for the applications have changed significantly, and so the PowerShell or the Node.js command line tool, you will typically need to do some modification there. We have a lot of examples on the website, but that is an area where you do go and do some updates. So now I want to kind of go through some of the key fundamentals that you need to think about, that's best to consider as you're deploying virtual machines. The first, storage ends up playing a big impact in your virtual machine performance. Similar to on-premise in an existing environment, to get the best performance out of something that has a lot of storage operations, you really want to have the right storage. We have two versions in Azure. We have what we call premium storage, that is really targeted at the low latency, high performance systems. That gives you up to 64,000 IOPS per storage account and more bandwidth on that. We're also seeing premium storage provide a little bit more reliability. It's built on newer hardware. It's a little bit more more processor capabilities. And so right now, premium storage is the best solution for running kind of the production applications. Even if you don't need the full performance, premium storage gives you some good benefit. But for something like dev test, or where you're not needing to have either the same level of reliability or having the performance of premium storage, we have standard storage, which is offered 2,000 IOPS per storage account. So we really recommend to have no more than about 40 disks in that storage account. Premium or standard storage then also gives you 500 IOPS per disk as compared to premium, that is up to 5,000 IOPS. And so there's a fairly big difference between the two, but you definitely have that option. Now, when you're using premium storage, it's not just the disks that you provision. And so one of the things I want to look at, it also makes a difference on the virtual machine that you have. So with premium storage, we've got the storage itself, which is all based on SSD. And when you provision a disk, for example, a P30 disk, it's 5,000 IOPS and up to 200 megabytes per second of bandwidth. That's what the backend can do. But you've got a VM over here that's actually sending data to that over the network. And there's a caching layer in the VM that you can optionally turn on. And the way that all of the VMs work is we partition those resources of the virtual machine based on the number of cores. So if you're running on the DV2 series, a D15 V2, it's the full VM. You have the full amount of resources on that physical machine to use. But if you come down and run on a D1, you have 1/20th, because you only have one core, of the resources of that machine to use. And so when you look at the disk and when you actually do a provisioning, you want to think not only how many disks and how many IOPS do I need, but what hardware on the compute side do I need to meet that? And so the best way to look at it, I'll just give you an overview. So I've got this virtual machine here provisioned with one cached disk that goes directly to the remote storage, and then one disk that is cached that goes to the local SSD, and then finally a local disk, the resource disk, that also goes to the local SSD. So to put some specific numbers on this, let's give you an example. So we'll start with a DS1. So the DS1 gives you 4,000 IOPS in the local SSD and 3,200 IOPS on the network, and then 32 megabytes per second of bandwidth on each. And so you can see when you actually set this up, that uncached disk, even though the back end, the storage can do 5,000 IOPS, you're only going to be able to max out about 3,200 IOPS on the actual machine, because that's what the network on that machine is able to handle. Similarly, on the bandwidth, 200 megabytes is what the backend can handle, but if you only have 32 megabytes to send for your disk traffic, you will get eventually throttle on that if you try to push it all the way up. Same thing goes on the local SSD. The local SSD gives you almost the 4,000 IOPS, so you can get close, but not quite reach it. And all of these resources double as you go up with cores. And so here we go to a 2-core VM, and as you see, both of these double. Now you can get the full IOPS out of either of those disks. But as you can see here, the bandwidth still is up 64 megabytes. So you're going to need to go to the DS4, which gives you 8 cores of the machine, and that gives you up to 256 megabytes of bandwidth. And so now you're meeting all the bandwidth needs for those disks. And so you want to think about these different layers. Think about the application. Most SQL OLTP workloads are very IOPS-centric, small I/O, so you want to look at the IOPS. If you're doing more of a data warehouse workload, it tends to be the bandwidth, and so you want to look at the bandwidth available. The next decision point you'll have is encryption. So with disk, and to get encryption at rest in Azure, we have 2 options for you. The first, and what we've had in market for a while, is what we call Azure Disk Encryption. This uses BitLocker or dmcrypt in Linux to encrypt the data disks and the OS disks on the machine so that anything stored in Azure storage is encrypted. It allows you to bring encrypted from on-premises and ensures that those disks are encrypted at all time while in transit and at rest. However, the Azure Disk Encryption is a little bit cumbersome to set up. You have to go and enable Key Vault. You have to get the key and pass it into the virtual machine, put the key into Azure Key Vault. So there's some challenges in getting it set up. We now have another option, which is storage service encryption. So what storage service encryption does is it does the encryption at the backend storage system. The keys are managed by the storage system itself. So it's very, very simple to enable. You click, create a storage account, enable storage server encryption, sorry, and then everything that you write into that storage account from the point you enable encryption on will be encrypted. And so that guarantees you have data encrypted at rest. The keys are kept separate from all of the data disks. And so if for some reason that those disks were ever to get out, you know that everything on there that was written there after you marked encryption was encrypted. Again, Azure Data Center, all of the disks, if you actually take a data center tour, you'll see stacks of machines where the disks are getting ready to be shredded. They are destroyed before they go out. But a lot of folks want to make sure you have encryption at rest just to be doubly sure. And so you have these two options. So let's look at this, and I want to go through a demo and just see how these different options affect the performance of your machines. So we're here in the Azure portal, and what I've configured is a machine that has a set of disks attached to this. And so this machine has 5 data disks. Zoom in here. So we have a standard storage disk, a disk that's premium storage that have configured for no caching, a disk that's premium storage we've configured for caching, and then I put a disk on here that's, again, premium storage, but then I configured BitLocker on the VM just to see what the difference is going to be on those machines. So here's this set the machines, and we're going to use Iometer, which is a test that really simulates workloads you can configure as you want. And so I've set up Iometer with a 75% read, 25% write, random I/O, small I/O that really kind of simulates a SQL OLTP workload. And so here on the standard storage disk, we're going to kick this off. And what we're going to see here is that the machine, let me zoom in here. Hold on one sec so I can zoom. And so we see right at the 500 IOPS that we're expecting to see. One thing to note here is now standard storage, here we've got about 30 milliseconds for the average I/O operation. So 530 milliseconds for that, for the standard. Now let's just move to the premium storage without caching. So here we're going to see the premium storage. Now we're up to 5,000 I/O operations and about 3 milliseconds on the average latency. And so we went up in an order of magnitude on the IOPS and down an order of magnitude in the latency. And so this will make a very, very dramatic effect on most of your applications that are using the system. However, this is, so we talked about unencrypted. Now we want to look at what does that encryption. So a lot of you, in fact, when I first saw this, I'm like, okay, encryption is going to cost me some performance. And so now we actually have the premium with encryption. Oh, let me close the first one. So again, no caching, but we actually have this encrypted. And now we kick this off. And actually we see we're still getting the 5,000 I/O operations. We're actually a little bit under 3 milliseconds, and we're not using any of the CPU performance. And so the back end, as I mentioned, the premium storage is a higher end system. It's got higher end CPUs. It actually does the compression, does the encryption very much in line, and you actually see very little to no penalty of having that encrypted. And so if you just, yes, question. Yes, clarification. This is with storage service encryption. So it's going to the back end. This is why we'll see that there's very low CPU utilization on the actual machine. So in fact, here if we go to, just to round that, now if we do BitLocker, so we were under 1% CPU utilization on the storage server encryption. Now if we're going to do the same thing, this is on my drive that is BitLockered. And now we see the BitLocker is actually using an extra 2% CPU from the actual guest VM. It gives you the same IOPS. We're still seeing 5,000 IOPS in 3 milliseconds. So the back end is doing its job, but now the CPU for the guest is processing every IO, encrypting it or decrypting that. And so that's where you have that CPU overhead. It's not huge, and in fact, it's for the option when we didn't have storage server encryption, the confidence of having your data encrypted at rest is very, very useful, but it is a little bit of overhead there for you. Now finally though, these are great, these are no cached volumes. We recommend on a workload like SQL that you always run with cached, and so here we're going to show the premium with cached. There it is. So this is what you would typically use. This is the same workload, same disk on the back end as a P30 disk, but we've just enabled the read-only encryption or read-only caching, and now we see much, much greater performance. Now we've actually tripled our IOPS. We're actually at 15,000 IO operations per second, and then our average latency is under 1 millisecond. This is because when on the cache side, everything's going through that local SSD. When you do a write, it's actually writing into the SSD. When you do a read of that cached information, it's reading out of the SSD, so it's much, much faster. So if you have an application that you're typically doing like a fair amount of reads, turn on the caching. The one exception, like for example, the log file that's almost exclusively writes, that one you want to configure as no caching. The one exception to that, which you'll actually see on our G series, our biggest VMs, the G5s, they have the ability to do so much disk and they have so much network that when you're doing a large bandwidth writes and large bandwidth reads, you can actually get more out of the back-end storage system because you can actually get that across 64 disks as compared to the cache. The cache will actually start throttling at 1.6 gigabytes per second, where the back end you can go all the way up to 2 gigabytes per second. All right, so that's a little bit on storage and storage considerations. Come back. So next, VMs. Has everybody seen this slide? I think Jason had it, and everybody had this slide. So let's have a little fun with this. I got another shot glass. Can anybody tell me or guess what the G series, the G was named for? Godzilla. I saw it right up here. Scott let that slip some time ago when in his thing. So what's your name? Brian. Shot glass for you, Brian. So the Godzilla. Oh, here's another one. Probably nobody knows this one. L series. Does anybody know what the L series is named for? Large. No, what was there? Leviathan. Good idea. Thought. No, actually, and I will protect the guilty here, but a woman's name is actually named after somebody in the team, and the namer is married, so we'll just stay away from that one. But L is named after somebody actually already. So, so the machines these are a set of machines. We've seen this before, but I just want to point out a couple things. So when you're looking at it, what I like to look at, we have this thing called the ACU. This is the Azure Compute Unit. And that is a relative CPU performance metric. It doesn't take into account memory and disk. And so what I've done here is I've given the ACUs, but I've also said, okay, what are the ACUs, 1,000 ACUs per dollar? And so as you'll see here, the A series, while that is the lowest cost machine on a per hour basis, you pay about 44 cents per ACU. If you flip over and look at the F series machine, you're doubling the ACUs, only going up a slight bit in cost, and so that's 27 cents per 1,000 ACUs. So depending on what you're doing, you don't want to just go absolute lowest price, and I've seen customers pull up like, okay, I need 2 cores, and I need 10 gig of RAM, and so lowest price, I do this, and you end up with an A basic, and it's really not the best performance. And so you definitely want to look at the ACUs. I'll also point out the H series, which we've just released. It's our top end on the CPU. 290 ACUs. And the ACU itself is really, people ask about this, it's really a metric used to compare only within Azure virtual machines. We don't try and say there's an equation of an ACU equals something else to other cloud providers, but it allows you to get an idea within our range of machines. The other thing you want to mention or think about is premium storage. So the D, F, G, and L series have premium storage enabled, and so that's a DS, FS, GS, and LS on those machines. And then finally, we've just released the enhanced networking that on the full-size machines gives you up to 25 gigabytes per second on the network for the machines. And so that's on our D, G, and L series that you can get up to that 25 gigabytes per second. You'll see enhanced networking come to more and more of the machines, but these are the three that you can get that really high end today. The next piece we want to look at is the images themselves. So the images, when you run a VM, you have a set of images that are available within the platform that you can leverage. So we have core platform images that come in Windows, Linux, and FreeBSD flavors. There's three types of these. And so these are either public, which is what you think of probably the most common, so like our Windows Server, Red Hat, those are our public core platform images. But then there's two others that you may not be aware of. One is MSDN. So if you have an Azure subscription that's part of an MSDN or Visual Studio subscription benefit, you have access to a set of images that the general public does not have access to. These are typically our client images. And so like, for example, Windows Client is available under MSDN only. And then pretty recently announced for those customers that are consuming Azure through an enterprise agreement, so that, larger customers or people consuming a fair amount of Azure, have a set of images that are available under there for the enterprise agreement customers. Specifically here, we get into some of the bring your own license versions of Windows and SQL, and I'll show you a little bit on that. They're available for Classic and Azure Resource Manager, and they're always available programmatically. These images you have access to by just signing on to Azure. The other class of images is actually a much larger number of images. This is what we call the marketplace images. These are provided by various third parties that publish those into Azure. They have several billing models. There's some that are free in trial. There's a set of images that are bring your own license, and there's a set of images that are per hour paid. The key thing with these images, and as you're doing automation and building solutions on this, is that the very first deployment either needs to be through the portal to accept the terms of this image, or you can go and click and programmatically accept the terms. And I'll show you how to do that. But it's very important because those images are not covered when you actually just have the normal Azure user agreement. And so you need to have this extra acceptance of the terms for those specific images. The other thing I want to mention is, for those of you using Windows in Azure, there's a thing we released earlier this year called the Hybrid Use Benefit, or HUB. And what that does is if you have Windows Server and you have a software assurance attached to that or associated with that, you can use your Windows Server licenses in Azure to cover Windows Server, the Windows Server charges in Azure. So if you have Windows Server Standard Edition, you can use a license to run 2 VMs that are 8 cores or less, or 1 license for 1 VM that's 16 cores. And again, if you want to go to a 32-core VM, you stack the licenses. And so that's Windows Server. If you have Windows Server Data Center on premises, you can continue to use the licenses on premises and use those licenses in Azure. And so that's a data center benefit. When you do this, when you use the hub benefit, you run the Windows VMs, but you only pay for the core compute. So if you look in our pricing list, it's the same price that you'd pay for just a basic link, but you're running the Windows VM, but you're not paying for those Windows licenses because you're using the hybrid use benefit. The question is, can you attach multiple SA agreements to that? I believe so, but I don't know. I guess you stumped me there on the shot glass. I can follow up with you afterwards and you get that detail. Licensing is not my forte, I guess. So now we've introduced the ability to, today when we launched this, you had to bring your image, and the hub VMs you have to deploy with PowerShell or the CLI tool and mark it as hub. I will show you an enhancement that just went into the Azure portal using those enterprise agreement images that makes this easier. So let me flip over and show some of these things here. So first, we've got a set of machines. I'm just going to go to the marketplace. I'm sure you've seen this before. This is where all the different images are available. And first, let me show you, Windows client. So for example, Windows 7, you'll see it show up here. I'm logged in with my internal subscription, not an MSDN subscription. And so when you go to click on that machine, you will see something that tells you, hey, this is not an MSDN subscription. Here's how you can go learn more about the MSDN subscription to use that image. Similarly, if we go to SQL Server, so if you look at SQL Server, there is a set of images, but let me zoom in, and you will notice that there are some, specifically this image right here, that is marked with BYOL. And so this is if you have SQL. Now SQL's had hybrid use benefits for some time where you can actually, if you have SQL with SA, you can use that in the cloud through what we call license mobility. But if you have license mobility and if you have an EA subscription in Azure, you can come, click on this image, and you'd be able to create a VM directly, and you won't be billed for SQL on that image. It would just be billed for Windows. And so here we see, again, I'm not running with an EA subscription, and it gives you some information. Here's how you can go sign up for that to get that agreement. If you have an EA subscription, then you automatically will be able to run that image. And as I mentioned, we do have now a similar Windows Server image, although there's a lot of Windows servers, so let me see, in here that will show up with the BYOL. It's down here. So here we see, this is the BYOL version of Windows Server. So if you go and run that, again, enterprise only available, you click through that and you'll run that and you just pay for the Linux rate. There's a bit of a trust, and so you need to register and make sure you've done the right things to use and have the right licenses. But if you do have those licenses, you can go through and run that. Now, one of the questions is, how do I know what these images are? They're not necessarily clearly marked. So let me just show you one of the images from the marketplace. So Barracuda is a partner that has a lot of security appliances, and they have a large number of images. So you see the BYOL versions. There is the pay-as-you-go hourly versions. And if we click on one of these images, two things you're going to know. First is you will see this box down here. Do you want to deploy this programmatically? Click here to get started. And if we click on this, it's going to bring up, it takes a moment because I've got a lot of subscriptions here, but it's going to bring up, and you can then programmatically enable, or you can see what's been enabled on this to run that image. And so, for example, you'll see here that I haven't enabled this on most of our subscriptions, but here, if I click enabled, then I'm accepting the terms of use of that image, and now I can deploy that programmatically. But now if I want to deploy that programmatically, how do I go about doing that? So when you deploy programmatically in a template, you have to set what's called a plan. And so let me fill this out real quick and show you how you get the plan information from that image. So put in the basic configuration information. I'm just going to select the default size. And as you go through, I mentioned that the Azure portal is built on templates similar to the templates that you as a customer can build. So as you click through, you'll find at the very end, you have this ability, there's again a little box down here, to download the template and parameters. So if I click on this, it's going to open up the template that the portal's just constructed that's going to be used for that VM. So if we look over here, this is our common template. We'll dig into some of these details here in a bit. Parameters, variables, the resources that get deployed. If we click on the VM itself, scroll down here, we're going to see that the instance has this thing called a plan. So you must specify this plan when deploying this image. And what happens there is that goes into the platform, and the Azure Resource Manager sees the plan, does a call over to the marketplace that says, hey, has this subscription accepted the terms of use through that enable button, or having previously deployed it through the portal? When you deploy it through the portal, you automatically accept the terms of use. If the answer is yes, then it allows that deployment to go through, and if the answer was no, then it would be failed. And so when you're deploying one of these third-party images in a template, you always want to specify that plan, and you can easily get that plan from this mechanism in the portal. All right. So now let's talk about putting those images into production. When we're running VMs in production, what are some of the key things you want to understand? First, let me just walk through. This is how Azure is designed with sets of clouds. So currently, we have 4 upper-level clouds, if you will. The Azure Global that you're probably most familiar with and here's talk about. Then there is Azure in China, which is a separate instance. You have a separate subscription for Azure in China, operated by 21 VNet. Azure US Government, which is, again, a separate subscription. It's operated by separate individuals that are cleared by the various security clearances needed for government works. And then we've just released a Azure in Germany, which complies with various German laws, has higher degrees of data protection, because the trustee that runs that you need to go through to get access to the data. And so it actually is able to achieve and meet all of the stringent German privacy requirements that is a little different than just the general global Azure. So then within each cloud, then we have what we call geos, geographic areas. And so this is where typically it's a tax boundary or some other data residency. So for example, we have multiple regions in Canada because the data residency expectations for Canada, especially in the banking sector. We have multiple regions in Australia for specifically more of a tax jurisdiction region. But we have these various geos that we organize things into. In any geo, with the one exception being South America, we have multiple data centers for high availability. Then it comes down to region, and the region is what you typically select when you're deploying a VM or a workload. And then finally, within the region, there's multiple fault domains. And so the fault domains becomes important when you're putting together an application. So when you're putting together an application, production application, one of the things you want to definitely be aware of is what we call availability sets. So an availability set is you describe machines that are part of the same tier of an application into the same availability set. So if you look here, we've got an app, the front end tier is in availability set 1, and the middle tier is in availability set 2. And that then informs the platform to take those machines and spread them across those multiple fault units within that data center. So that guarantees that you have reliability. There's no single point of failure within those 2 machines. And the fault units typically are in Azure a rack, because each rack has a single top of rack networking switch and also has a single power distribution unit in that rack. And so there's 2 physical components that could fail that would actually bring down the entire rack, and that's why we separate those machines across racks. So that's if you're deploying an application in region for high availability. The other model is multi-region deployments. Now, Azure also takes the next step and says within every region, there's a paired region to that. And between those 2 paired regions, we never make updates to the software at the same time in both paired regions. And so when you deploy, if you're deploying across multiple regions, you want to look at the Azure paired regions documentation, and then deploy into those 2 paired regions. You tend to have then availability sets on each side, and then you use the traffic manager, which is a DNS load balancer at the top to spread the traffic. It depends on the application. Designing an application that works active in a multi-regional environment and having data replication you can do with some applications, not all. Deploying a high availability using availability sets is something most applications can do. And then if you don't use the high availability, you can still go down and just deploy individual VMs. The case with the individual VMs, though, is that we will have to update the software on those VMs. Currently, one of the questions we get is like, how often are we doing updates? Right now, we do an update about once every year on the hypervisor, or I should say, an update that you see about once a year. That takes the machines down for about 20 minutes, and you have a notification a week in advance. Any other security update within Azure, we have a thing we call in-place live migration using some functionality that was developed by Windows and Hyper-V. So your VMs, if we need to, let's say we need to patch the kernel because of a security fix that goes out, the VMs stay up. We actually are able to patch the kernel and do a fast reboot of the host, keeping all of the VMs in memory, everything running. The VM, you'll see a pause of a few seconds, but then the thing comes up and it keeps running. And so most customers, you don't see that this VM's been paused. You don't see any impact there, but we did actually update and keep the host always running fresh. We're introducing a thing called Cloud Control that's going to give you a notification if you want to pick up on when we're going to do those pauses. But again, it is just a few seconds. I think our 99th percentile is like at 9 seconds on those. Okay, the next thing is backup. So when you're running an application within Azure, a production application, you definitely want to look at and make sure you have backup solution. Now, because these are VMs, you can use just traditional backup solutions that you would have on premises, but we have a built-in backup solution in Azure that makes this much easier. And let me just show that real quick. So what I've done here is I've configured a recovery service. Recovery service is the recovery service vault is the vault that holds backups and Azure site recovery. So in this here, let me bring up the vault. And so in the vault, you have a set of options. And I went through and did the initial configuration, but there's a set of backup policies. So the backup policies allow you to specify the default policy, which is, I'll show here, the default policy has, oops, too fast. The default policy backs up a machine once a day and then maintains that for 30 days. If I want to do something more advanced, I can come in here and say I want a new policy, and we'll say this is a little bit robust policy. We'll keep a VM backed up for a daily for 60 days, then we can do a weekly. Let's say I do a weekly, keep that for a year, and then maybe I'll keep 60 monthly backups, keep each of those, so I got 5 years of monthly, and at that point in time, I don't think I need to keep yearly backups. And I can create that policy, and now that policy can be used. Now, you can configure VMs to be backed up in this UI itself, but we're in the process of making that much, much easier. So here I've got a machine that I've just deployed a bit earlier, and I've actually enabled, this is, as you see up here, it's marked as preview, and one of the reasons is that we're living in the future a little bit here, and now this VM in the portal now has this backup action on the VM. You'll see this in general release in about 1 to 2 weeks time, but here I can click in backup for the VM. It's going to go and look to see if we have any vaults configured. If I didn't have a vault configured, I'd go through and create one. I'll select this vault that I had configured. I choose the backup policy that I want to apply, the default policy or this more robust policy that I had just created. Click OK. And now it's going to enable backup. Now, the way that backup works on the virtual machines, especially on the Windows virtual machines, is it installs an agent into the guest. Windows has a solution called VSS, which is the Volume Shadow Copy Service, and that enables backup applications to interact with applications that are writing data, for example, like a SQL. So SQL writes data to a log file and to multiple database files, and so by coordinating with the SQL server, to quiesce the operations and then take the backup. Now, while that's installing, I actually have another machine. So if I actually already set up backup on here, if I've already set up backup, I'm going to click on here. Instead of that same experience, I'm actually going to go to the backup management, and here I can do backup now. I can see the backups that have been created. I could click on one of these, restore to that instance, and do what I want there. So it makes it very, very easy to get backup on your VMs. Question?
If you do a backup now, does that go against your retention, or does it sit outside?
If you do the backup now, it would be retained for the same count as those others. So it's not completely outside of the retention period.
So potentially, get outside of your 30 or 60 days if you took a manual backup.
If you remember, the retention is the number of instances, and so that would be, actually, let me go back. I need to check on that. Shot glass for you. Because it's the number of daily backups to keep. So I think that goes against daily, but I'm not. I'll check on that because I'm not 100% sure. All right, so that's backup, making it easy. And you'll see us do more things like site recovery. We're integrating site recovery into Azure virtual machines. As that comes online, you'll see those kind of things light up within the Azure portal. The thing I want to mention is ARM policy. Who's heard of ARM policy? Is anybody using ARM policy in here? Okay, so ARM policy, as I was expecting, it's a very powerful but not well publicized solution. What it allows you to do is it allows you to set specific policies that you want to be applied for every resource that is created in your either subscription or in a resource group. And so, for example, things that you can do with ARM policy, you can set naming convention here, so you can set a prefix with a wildcard on how you want your instances named. You can limit the services, so this is limiting the various services you can deploy within that subscription or resource group. Geo controls, require billing tags. There's more and more things you can do here. For example, on VMs, we see customers using the ARM policy to restrict which marketplace images that their customers can deploy, or even which custom images can be deployed through the ARM policy. Right now, you must use PowerShell or the CLI to configure ARM policy. And that's why it's not well seen and used. You'll see this coming into the portal here shortly. That's going to make it a little easier to go and use ARM policy. Azure Security Center was released last year. The Security Center pulls together a lot of the best practices that we have around securing virtual machines. It'll give you a notification if the VMs need to be updated or patched. It gives you notification if they're running endpoint protection or not. And so it's a very, very useful solution to look at for your virtual machines. It allows you to keep your security posture very strong through this automated system. Additionally, if it sees something very anomalous, it will actually notify you through alerts. So for example, if we're starting to see attacks coming from a region and it's hitting maybe not you, but it's hitting other Azure customers, we're actually looking across the traffic we see across thousands and thousands of customers, and that we are able to pick up some trends and actually work and leverage those, both to protect our customers and to work with authorities to make sure the bad guys get taken care of as fast as possible. So with that, let's move into VM templates. So with a template, the basic structure of a template is the set with the schema, content version. Schema defines the resources that you're going to deploy, or the schema for those resources. And what you end up configuring is typically these middle three: the parameters, variables, and resources. The parameters are the things in the template that the customer deploying the template can select, and so they can be strings, secure strings, booleans, ints, or kind of enumerated types. Variables are variables used in creating the resources, and then the resource themselves, these are the individual ARM resources that get created. Optionally, when you do a template, you can have an output parameter. This is really often used when you have a template that then deploys another template that we'll see in a moment. And by using the output parameter, you can return things like a connection string for SQL or the IP address that was configured. Question here. The question is there any way to validate kind of a customized template before being deployed? Roughly, yes. Yes, and so there's an API for validate template that you can call, pass it the template, and it will run through that validation. The same validation, you see the portal calling. And what that does is it passes the template down to all those resource providers, and those resource providers go and do checks against the common things. So like the uppercase letter in a storage account will be checked there. Okay. Yeah, grab me afterward and we'll walk through that. Okay, so the next thing here with the template, there's functions available within the template language. The most common ones you'll see, parameters to actually fill out a parameter when you want to use that, variables to evaluate the variable, and concatenate strings so that to fill out a name. So for example here, we've got the subnet ID, then we're going to concatenate the VNet ID with the word subnet, and then the subnet name. So when you have to create a subnet ID, you use this functionality. There's a large number, the copy index is another one that you'll see commonly used. So what the copy index is used for is it's used within the creating resources. And so you can specify the number of resources to be created here. And so you can see here we have the parameter, there's a count of 3. And then by using the copy index in here, we create a storage account with 0, 1, and 2 as the name of the storage account. And it creates by using that copy index. Some of the other functions you'll see in here, resource ID to get the resource specific ID, listing keys for a storage account, getting a unique string, especially there's a set of properties that need to have unique names. Storage account is one, DNS name is another that needs to be globally unique, and so the unique string is very, very useful. Other things only need to be unique within the resource group. To lower and substring helps you kind of actually put things together, pull things apart. And there's a large number of lists, a large number of functions that's available on our documentation. There's math functions and such to actually do what you need there. So what I want to do is look at just building a basic template. We're going to start with the resource group. All templates are deployed into a resource group, and so when we talked earlier on how you do a deployment, if you're separating one resource group for all of your resources or separate ones. If you're doing separate resource groups, you will need to do separate templates into each of those because a template is scoped to a resource group. So we create a resource group. We're going to have a VNet and a subnet. We're going to create a storage account, put a storage account in the template, a public IP address, and then associate that with the network interface card, and then spin up a VM. And so let's go in and do this here. I'll just show you how to walk through that. So creating a template, one of the ways that I find is the easiest to go create one from scratch is here in Visual Studio. You can really use any JSON editor. You can use Visual Studio Code, or for that matter, any text editor to build these. But there's a couple capabilities within Visual Studio that is kind of nice. So we're going to create a new project. And if you've installed the Azure tools for Visual Studio, you will see that there is a project type here. It's called a resource group project. So we're going to create this resource group project. And we have a set of starting points. Some of these you see look familiar from the portal, but for demonstration purposes, we'll start with just a blank template. And so it's going to pull those resources together, build the basic template. Azure deployed.json is what we tend to use for just the recommended base template. And you see you've got the parameters, variables, and resources already set up here. And so now, as we said in the solution, I right-click on a resource. I want to add a new resource. We're going to add that virtual network. Scroll down here to the virtual network, my VNet. And as you see here, it put in the VNet resource as well as a set of variables associated with the VNet, the name of the subnets, and you can then go and add additional subnets to that as you want. Then we're going to create a storage account. So we'll scroll down here and create an Azure storage account. Again, here now we've actually it created both the storage account and a parameter here. If we actually click on the parameter, we can see that it's created a set of parameters. It allows you to enumerate what type of storage account you want, whether it's a standard LRS or premium LRS storage account. You can modify this. Actually, for a VM, we can't use the ZRS is not available with VMs, and so I could go and remove that as I wanted here. So from here, we got the storage account. Now we needed an IP address. Let's create the NIC. So So we go down here and do a network interface card, attach it to whichever subnet we want or create a new one. And we'll add the IP address to the VNet, or to the NIC, sorry. So we have a public IP address associated with the NIC. And then finally, we're going to put our VM in here. So add into VM. The two VMs we have defaulted in here is a Windows VM or an Ubuntu VM. We'll select the Windows VM here and select the subnet that we're going to connect that to. And so now we've created, so just by clicking through a few things, we end up with a template that's got all of the different resources that we need to go ahead and get started on that. Now that's one way to get started. Another way, and a powerful way, is a set of templates that we have already created. So if you come into Azure.com, and if you go to Resources, you will see a large number. Currently we have 416 templates. These are actually all sourced out of GitHub, and so if we actually click into this, you will see each of these. Actually, you can go and do a browse on GitHub. So let's go over to GitHub for this. And here, under the Quick Start template, you're going to see that we have, the 400 templates. They're arranged with a set of 101 and then 201 templates, so you can get started on basic things, basic operations. Then they go down into more advanced operations, such as setting up various applications, setting up Splunk on the machine, or a bunch of different options here. And so that's kind of either build it from Visual Studio or starting from one of these existing templates and modifying that is really the two operations that are the best way to get started. Now I want to come back and just point out one more thing, and then we'll dig into another template. So the next piece is injection of code. And so within the virtual machines, we have this capability we call extensions. And extensions are a way to inject code that's a curated piece of code and configuration into the machine. And so one common way that we use an extension is for anti-malware. So you can inject the endpoint extension into the virtual machine, whether it's a Microsoft anti-malware, semantic anti-malware solutions that you can actually inject into the machine. Within the templates, we see a ton of use of either desired state configuration of a PowerShell on Windows machines or custom script extensions. This allows you to put that extension into the machine, give it the desired state configuration or script to run, and it'll run that on that machine and configure the machine. This allows you to do some very extensive capabilities, such as setting up a complex application like SharePoint. So let's actually look at this here. We'll go back to the table here. Now within Azure, let's go ahead and just look. So we've got several options. The SharePoint area, so let's search for SharePoint. So we've got a 3 VM SharePoint, where there's an HA SharePoint. If we go to the 3 VM version, it's actually the same template that's used in the Azure Marketplace. We just have put this up here on GitHub so that others can take it and modify it. Gives you a little bit of overview on it. And if we actually browse this one on GitHub, what we're going to see here is a large number of templates. So the SharePoint template starts with a base template and then launches additional ones. To get a little bit better view of that, we have a thing called ArmViz, which is an open source project that we've been running. If we bring up the visualizer, it's a quick way to see what the template's doing. And let me zoom in on this. So you can see it builds up the dependency graph. So for example, the very first things it's going to do is setting up a virtual network, setting up the IP addresses and for SharePoint and the other public IP addresses. Then it configures storage accounts, creating the availability sets, goes and provisions the machines, and then as you can see here, so updating AD has a dependency on the machines getting provisioned, configuring SQL, and on up. And so you can get a visual view of these. You can double click into where that is in that template. instead of waiting for that. So you can get the details of where that is. As you mentioned before, the code injection, so the SharePoint template makes extensive use of desired state configuration. So in here we have the various desired state configuration templates for creating AD, creating SharePoint. So you can go and use the fragments of this template, the DSC configuration. If you need to just set up AD in a template that you're using or set up SQL in a template you're using, you can start from this point to go and configure as you want. So once you have the VMs, you have everything up and running, we want to make sure that you have a great experience around keeping them running, and if anything goes wrong, we want to make sure that you're able to get support and troubleshoot your problems as quickly as possible. So I want to show you just a little bit of what we've been doing and investing to make sure the troubleshooting behavior is very, very straightforward. So here, let's come back to the portal. So I've got a machine that I've set up to show off a little troubleshooting. So I've got this machine, I deployed it, it's been running fine, but for whatever reason, currently I cannot connect into it. I do click on RDP, and I'm not able to connect into that. What we have is the place you want to start for this is diagnosing and troubleshooting problems section. And if we bring this up, we're going to first see that we're running a thing we call the resource health check. So here, in the top you see, we go out and we look at all of the telemetry we see in the platform to see from the platform's perspective, does the VM or does that resource, it's actually available on all of the resources, appear to be working correctly. And in fact, it'll tell you the current status as well as what was the activity for the last 24 hours here. And so if the machine is currently working, but it was down, maybe there was a hardware failure a couple hours ago, it would show up here and you could say, oh, that's why maybe I wasn't able to connect because I had this hardware failure. In this case, it's showing as it is healthy and working, so I need to figure out what's going on. I have the option, so now I'm saying, hey, I can't connect to the machine, and it's going to show me a set of recommended steps to take. So we can look at the console screenshot to see if it's bug checked or something's wrong on the machine itself. Scroll down through here. And so one of the things I want to highlight, and say we've gone through each of these items, we now have this thing called the effective security group rules. As I mentioned, the security groups are very much like ACLs. You can apply them on various IP addresses, various IP ranges. They can be applied to the virtual machine, or they can be applied to the subnet. And like ACLs in on-premise and other environments, they're very, very powerful, but they can be, if used incorrectly, it's very easy to have this notion of like, hey, I'm getting blocked by a share ACL on a file server, and it's blocking me to actually access the file, and how do I figure out what that effective ACL is? So what we've done is we've brought together this thing called the effective ACLs, or the effective NSG for your VMs. And so what you see here, I can select the specific network interface. I only have one NIC on this machine. And then on this machine, it's having two things applied to it. One is the VM's network security group, and then the second is the subnet network security group. So if I see on the VM itself, the effective ACL here on the VM is allow RDP. I've got a priority of 1,000, so I should be able to get access to that. But if I click over here and notice on the subnet, I actually have a deny RDP. And so from that standpoint, that's likely what's causing me to not be able to connect to that machine. So I can look at the deny RDP ACL. It gives me some no additional information there. But I can click here to go over and modify that. And here's this deny ACL. I can come in here to this deny ACL and remove that. And now that'll get removed out of the subnet, and then I should be able to connect into that machine. Now, for some reason, if I do that, I'm still not able to connect in, then you can come in. You may want to phone a friend here, call support. So we've got the Help and Support Center that makes it very easy to come through. We've brought some of the common resources that you may use, documentation, MSDN, Stack Overflow into the process. We're creating a support request. You're just going to fill out some basic information here. And so, right here we've got a technical issue. There we go. On this subscription, it's the bottom subscription here. Oops. A lot of testing subscriptions. Say I work on the team. And then here it's on the Windows virtual machine, a virtual machine with Windows. And then it's going to load the resource. What resource are we having a problem with? It's the one we called troubleshooting. And then our support plan. It's going to recheck this using the resource health check and says, hey, we still think it's good, at least on the platform side. Click through. And as we go through and enter the problem, a little more details, we see the connectivity. So again, we're going to bring up and say, hey, if you can't connect to the machine, did you go through these steps? And so get the troubleshooting help for you again. When you fill out the information, unable to RDP, we're also going to go back and see, hey, maybe there's something in Bing or Stack Overflow, and so we're actually going out and pulling results back off of the web and live here and say, hey, here's some other information. Again, as we go through this, as much as possible, we're trying to make it so that if there's a solution that can help you without having to actually create the support request, that we get that to you. But once you create the support request, you have all the information you've already provided to them. In fact, now you can actually opt into, opting in for some diagnostic information that tells the support team, yeah, you can go ahead and get a memory dump of my machine and start debugging there. And the unable to connect, if you go through these steps and it's still not connecting, the most common thing that we have seen is something is hung actually within the Windows guest. By doing that memory dump, by the time that gets processed and by the time you get into the support, they've already got that processed and can have a really good idea of what's going on that machine and how to fix that. So that's just some of the stuff that we're doing to make it easy to have support. We'll continue to enhance that. And so definitely, if you see an issue, if you're having a problem, click on that troubleshooting blade and we'll get more information there for you. Question? Yeah, it's a great point. So the comment was make sure to look at the boot diagnostics. Actually, that's the very first thing in the troubleshooting is click on the boot diagnostics. Sometimes I've seen it setting at loader. Or a common problem that we've had is somebody generalizes the machine but doesn't register it as a general image, and so it's setting in setup. And so there's a lot of things you can learn directly from that console screenshot to debug those things. Okay, so we've gone through and just covered, some of the how to migrate Classic to ARM, some of the differences between Classic and ARM, the configuration of the machines, how to troubleshoot and run these in production. And I just hope that you've able to take a few nuggets away today on best practices for the virtual machines, how to use those and be very productive. There's a set of resources here for additional IT Pro resources to use to learn more. I want to thank you for your time today and at Ignite, and I have a handful of shot glasses if anybody is interested. Let me see if I got a good question here. Oh yeah. Okay, here we go. I got a question. Tell you what, let me answer. For those of you guys leaving, do please fill out feedback. Give me the information. What if this kind of content is what you're looking for? Too deep, too shallow as you go forward, and so we can actually have an even better Ignite as we move forward. So thank you, everybody.